Hello and welcome to my video on some of the questions from the Dynamics Google Forms review, the Google Forms that are prior to the quiz. So these are some of the questions that were brought forward to me by one of the students here, and so I'm just going to go through them one at a time and explain them. So here a block of wood is sliding on a skating rink. So I'm just going to draw, I always start every question just drawing a free body diagram, or at least a little bit of a picture. Hits a rough patch of ice which exerts a resistive force of friction. So here's our force of friction. Obviously it has gravity and normal force. Okay, determine the distance the wood travels before it comes to rest. If we're talking about distance traveled, I mean, hopefully we have a little bit of a gut reaction back to kinematics, where we have all of these different values here, all of these different variables. We're looking for the distance traveled. We don't know a lot of different things, but we do know the initial velocity, and we do know the final velocity because it comes to rest, so it's 0. And we can figure out the acceleration pretty easily, so we're going to cross out time. How can we figure out the acceleration? Well, we're going to use our free body diagram. F net equals ma equals all the forces added. In this case, there's just one force, the force of friction. And so we're going to solve for a by going force of friction over m. We can then put that number back into here, or back into our formula. So Vf squared equals Vi squared plus 2AD. And we're going to solve for d. So we're going to go Vf squared minus Vi squared equals 2AD. Now we're going to solve for d by dividing by 2a on both sides. And so all of this is perfectly correct, but all of that's just kinematics. So all we're changing here is, instead of putting a, we're going to write force of friction over mass, which is our a value here. I'll leave that arrow there. Okay. Yeah, you know what? I'll pull it up. We're going to go ahead and press alpha y equals enter to get a fraction. Then we're going to put in our final velocity. Our final velocity is 0 squared minus our initial velocity, which is 12.5 squared, over 2 times by a. Well, a is a fraction, so I'm going to put another fraction in there. Force of friction is 30 over the weight, or the mass, sorry, I said weight, of 6. And all we have to do is now plug it in. Now, why is it negative here? Well, I called accidentally, not really on purpose, but it's going to be a good conversation here. I called this way positive because I made friction and acceleration positive. But obviously, sorry about that. Obviously, the displacement is in this direction. And so when it's asking the distance, it's going to be 15.6 or rounded to 2 sig digs, 16 meters, which is matching what we would expect. All right, let's keep going. I'm not sure if both of these are ones that wanted to be answered, but let's take a look at this one as well. A baseball comes across a plate horizontally at that speed, makes contact with the ball for that many milliseconds, sends the ball in the opposite direction at that speed. What was the average force exerted by the ball? Well, if we're looking for force, so first, I always kind of based off of what we're looking for. So we're looking for the force, which is going to be F net equals ma equals our force applied, because in this case, we just have one force pushing forward on the ball. That's the force of the baseball bat, the force applied. So we're looking for that force applied. So what we need to do is get the mass and the acceleration. We know the mass already, which is fantastic. But again, we're going to use our kinematics kind of ideas. So Vi equals And right now, I'm going to call kind of to the right positive. But VI, the ball comes in this direction. So VI is a negative 50 meters per second. VF is in the opposite direction, as it states, in 60 meters per second. Acceleration is what we're going to look for. And we know the time because it tells us 125 milliseconds. Now, milliseconds, unfortunately, is not very nice. We want to change that by dividing by 1,000 to get our seconds. Just like we divide by 1,000 to go from meters to millimeters. But also, if you look in your formula sheet, there is a description table that helps you with those prefixes, like milliseconds. Anyways, that is correct. So D is the variable we do not care about, which means we're going to use the formula A equals VF minus VI over T, which we don't need to rearrange. We're just using A directly. And we can then plug it back into this equation here instead of A. The big trick, I think, for most people is the fact that these are in opposite directions here. And so one is positive, one is negative, but it says opposite direction. So that's probably where most people would get messed up. But we're going to go ahead and now write this in our calculator and see what we get. So first of all, the mass is 0.65. You could put the 0, but who cares? Times by, bracket, fraction. VF is 60 minus VI, but VI is a negative 50. So minus a negative, well, that's going to give us a positive, right? And then over 0.125, that tells us the number of seconds. And so we're going to be left with 572 newtons. So that's going to be our final answer here. Okay, let's keep going. Oh, this one's missing some parts here. Maybe we'll go back and take a look afterwards. Just notice that what I want you to notice right now is that the force of B on A is the same as the force of A on B, except that it's in the opposite direction. Maybe we can... yeah, I know that this question is something like this with two different blocks. I don't remember which one's A, which one's B, and then there's a force applied over here. But I don't have the details here. Okay, let's take a look at the next one here. A 490 gram cart experienced a forward force of 6.5 newtons and a backward force of 1.8 newtons. If it starts at rest, how much time would it take for the object to travel 22 meters forward? So again, there's some kinematicsness here because it starts at rest. It's telling you a distance. It's asking you how much time. So VI equals VF equals, so VI is 0. VF we don't know. A we don't know. D is 22 meters. And we're asking about T. We can find A somewhat easily. The A is always the part that's the same between a dynamics and a kinematics question. It's always acceleration. That's going to help you go from one to the other. Okay, there's a forward force. I'm just going to say it's force applied. And a backward force. I'm just going to call it force of friction. Yeah, so there might be a normal force up here and a force of gravity down here. But if we do an Fnet statement here, equals MA equals all the forces added, we only add in the direction of motion or the direction that it's actually accelerating. So like this. Then we can go ahead and divide by a on both sides. Sorry, divide by m on both sides. And so now we can use that in our kinematics question. Our kinematics question is going to use d equals VIT plus a half AT squared. Is it plus or minus? I'm using my memory here, so if I make a mistake, I apologize, but I believe that's a plus. And since VI is 0, we can make that whole thing 0. Now we're going to rearrange and solve for t. So we're going to multiply by 2 on both sides, divide by a on both sides, and equals t squared. Now we're going to square root both sides. So t equals the square root of 2d over a, which is great. But we know a from the previous part is going to get plugged in here. So a is going to be force applied minus force of friction over m. If you do this in 2 separate steps, that's perfectly fine. I prefer doing the algebra because it's less calculator work. I don't like using my calculator if I can help it. So square root of a fraction, 2 times d is 22, over another fraction at the bottom with force applied, that's the forward force, 6.5, minus the backwards force of friction over mass, which is 0.49, because we have to change it to kilograms. And we press enter, and we get an answer of 2.14 whatever seconds, which is 2.1 seconds with SIGDIGs. Okay, here you go. I think this is the one that we are going to use for the other questions. So let's go ahead and go back to that one. So the questions were, just so we're clear, what is the force of A on B and B on A? So let's just do A on B, and obviously it's the opposite the other direction. Okay, so here are the force, the situation. A has this applied force on it. Someone's pushing A, and A then pushes into B. But this force is on the whole system. So what we're going to do first is go F net equals M total A equals, and then all the forces added. I think there's no friction, if I remember correctly, for this one. It probably says down here, but let's pretend there's no friction. So it's just a force applied forward. There is force of gravity and force of normal, but those can kind of be ignored because they're not going in the direction of acceleration. So we're going to solve for acceleration first. So force applied over M total, which again is both masses. So I'll just say force applied over MA plus MB. Okay, now we can use that acceleration by zooming into just B. So we want to know the force on B. Well, what we're going to do is we're going to do the F net on B. F net on B is going to look like this. Well, it only has one force applied on it, right? But we know it's the same acceleration because both blocks are moving at the same rate. So if we know the mass and we know the acceleration, I mean, it's just a straight up calculation. All we have to do is take this A value and plug it in here, and it should all work. So let's go ahead and just rewrite it so it's nice and clear. Okay, so this is going to be a fraction, mass of B first, so 32 times bracket a fraction. The force applied on total, I'm going to make this force applied T for total, and this is force applied B, just so we're very clear, or on B. So the total. So this is going to be 2 to 1 over mass of one, mass of the other, bracket, enter. We get a little fraction thing, but that's okay. If we press math and then decimal, we can change that to a decimal. And we get an answer of force applied on B is 150 newtons to the right. Because that's the force on B pushing it forward. Whoops. Which again matches up with what it says here, force of A on B. And then you can look and say, well, it must be an equal and opposite reaction, so it's a force of friction, force backwards on A to the left by the same amount. All right, I hope this video helps you better understand some of these questions, and good luck.